Today we are going to talk about inverse functions. This is something that you would have talked about before in Algebra 1 and possibly geometry and possibly some earlier classes. But we also saw it in our exercise graphing the exponential and logarithm. So we're going to jot down a couple of key points or main points about inverse functions onto our note sheet. This can go in that main point one section. The first thing an inverse function does is it undoes the action of the original function. So if I give you a problem with addition, the inverse of that is going to be subtraction. If I give you a problem with exponential, the inverse of that is going to be logarithmic, and vice versa. So main point 2 is that in undoing this original action is actually going to reverse the x and y values that we get from our function. So if I gave you an original function here of right here, the one that I kind of highlighted in red, I listed out all these made up x and y values. So at -2, our function is equal to -10. At 0, our function is equal to 0. What happens with our inverse function is these flip around. So our inverse function, instead of having a x value of -2 and a y value of -10, it flips, where we have an x value of -10 and a y value of -2. Similarly, in this next row here, instead of -1, -5, it becomes -5, -1. 0 and 0 do flip, but I mean, it's the same thing anyways. And the last one, 1 and 5, would become 5 and 1. What this means for us graphically, and this is what we saw in our Wednesday Explore activity, is that our inverse graph is going to reflect over the diagonal line y equals x. This diagonal line here, which I'll draw in blue, we can jot on our sheet, is the diagonal line that perfectly crosses in between our axis, and it runs smack dab in between our y and our x axis there. What's going to happen then is our inverse function, which I'm going to kind of draw in red, is going to perfectly mirror what's happening over that line. So it's going to kind of start down here, bend up, and start bending away from our original function. And I didn't draw that perfectly, I know. But the key point is that if we tilt our head, we can see that reflection over the blue line. So now that we have a good understanding of what an inverse function is, we are going to actually calculate and find some inverse functions for different logarithmic and exponentials. So in the section of your notes titled Finding Inverse Functions, let's jot down these 3 steps here. First thing we're going to do is switch x and y in the equation. Then we're going to rearrange the equation so that y is by itself. And then, if desired, we are going to switch the equation sides. And you'll see what I'm talking about in number 3 in just a second here. Let's see how this plays out in example 1. I'm given the original function y equals log base 9 of x minus 3. So if I kind of follow my steps here, I'm going to go step 1, switch x and y in the equation. So x equals log base 9 y minus 3. All I did was rewrite everything exactly the same except the x and the y switched around. Then I'm going to start rearranging the equation so that y is by itself. So I want to get y all by itself. To undo that, I need to start writing in an exponential form. So to do that here, I have 9 is my base, x would be my exponent, and that is equal to y minus 3. Okay. And then I want to get y all by itself, so I got to add 3 to both sides to move that over. So I would get 9 to the x power plus 3 equals y. And finally, this last step here, number 3, switch the equation sides if desired. That's really only if we want to have that y listed out on the left-hand side. It's usually a little easier to read that. So I'm just going to move this y over here, and we have y equals 9 to the power of x plus 3. Again, that final step you do not need to do unless you want to. All right, let's try this now on example 2. So we first want to switch x and y in the equation. Again, I'll try to color code this as best I can. So simply x equals log base 2 of y plus 6. Then we're rearranging so that y is by itself. Looks like, again, here we can rewrite in exponential form. So 2 to the power of x equals y plus 6. Then I can subtract 6 from both sides to get y by itself. So I'll have 2 to the power of x minus 6 equals y. And finally, if you want to, which I always like, I'm going to rewrite this so that my y is on the left-hand side and it looks nice and clean. So y equals 2 to the power of x minus 6. All right, one more example that we're going to go through as a class, example 3. You'll notice that if we look at this example here, we now have something happening outside of the logarithm. So before we can do anything here, we actually need to move that 5 all by itself. Although I am jumping ahead of myself a little bit, I guess first thing we got to do is switch x and y in the equation. Let's do that first. X equals 5 plus log of y. Make that x a little cleaner. Now we can deal with what I was talking about, where we got to deal with this 5 and rearrange it and move it to the other side before we can take our exponential. So I'm going to subtract 5 from both sides here because right now it's being added to our log. Okay, and this is what I'm doing, rearranging the equation. So I get x minus 5 now on the left. And that equals to log of y. Okay, now I'm in a spot where I can take my exponential. We have a base 10 log because the bases are written. And so our entire exponent is this x minus 5 up top. So 10 to the x minus 5 equals y. And finally, if we want to switch the sides of the equation so it looks clean, we'll have y equals 10 to the x minus 5.